You're probably wondering why you're seeing a video about multiplication before you're seeing a video about addition and subtraction. And this is kind of, I don't know, a running gag that happens in high school, which is that very often multiplying things and dividing them is actually easier than adding and subtracting them. And this is no different. So we're going to talk about multiplying terms together. Okay? Now, this is one of those things where by making things slightly more confusing, we're actually making them slightly easier to do. So I will give you, let's just underline my title like a good student, an example you absolutely know how to do. You know how to do 3 times 5. That's 15. Now, what you might not necessarily know how to do is, let's say I have a variable a. What is 3 times a? Well, it turns out because when we use variables, we're separating deciding what to do with the numbers from actually calculating and carrying the 1 and worrying where the decimal place goes and that sort of thing. So 3 times a is just, in our lazy way of writing it, 3a. So in order to multiply things, you just have to write them beside each other. You don't have to do anything yet. We don't have to care what 3 times a is until somebody decides what value the the variable a is going to take on. It can just sit there, and it can sit there for a very long time. So 3 times a is 3a. And the same thing, we just take out all the time signs. What is 3 times a times b? Well, that's just 3ab. Easy. What about a times a? Well, we have a short form for that. It's exponents. That's a squared. Okay? And now you can do basically everything. So let's do 3 things. We're going to do a, we're going to multiply it by a new number, b, and we're going to multiply that by 3a. First thing to remember is that in multiplication, the order does not matter. 3 times 5 and 5 times 3 have the same answer. 2 times 3 times 4 and 4 times 2 times 3, whatever the order, has the same answer. So I can write this as a times b times 3 times a, but I can also put the 3 first. This is 3 times a times b, and I know from up here that a times, I should be putting equal signs here. It's late, I'm getting lazy. This is 3a squared b. Okay. What happens if there is a negative? So this will be, let's change to a different one. This will be c times -6. Well, it's just -6 times c. And this is another one of those convention things where we tend to put number first, letter second, and if there's more than one letter, like for example this one here with a and b, or this one here, a and b, the letters in alphabetical order. Does it have to be that way? No, but if we're all doing the same thing, it means that everyone can read each other's work a little bit more easily. Okay, let's get a new page because we're running out of space. How about we'll do -3 times -4 times x times y squared times x squared. Lots going on, but still not hard to do. All right. Now, anything you can do, you should do. So, for example, here, I know what the answer to -3 times -4 is. That's just +12. The other ones is a little bit more difficult. So this is times x. Now, I'm going to write this out the long way, and in a second I will show you how to not have to write it out the long way, if that makes sense. So, no, that's not what I wanted. Y squared is times y, and x squared is x times x. But now I can rewrite any order that I want. This is 12 x times x times x times y, and I know I can shorten these three and these two. 12 x to the power of 3, because there's 3 of them being multiplied together in a row, times y squared. Okay? So the shortcut, I'm just going to copy this a second time. -3, -4, x y squared, x squared. Make sure my 2 looks like a 2 so nobody gets mad at me. So here is the shortcut. You do it in 3 parts, more depending, you'll see in a second. So first thing is the sign. So I look and I see a negative times a negative. Well, a negative times a negative is a positive. So if there's 2 negatives, or 4 negatives, or 6 negatives, I know that my answer is going to be positive. And depending on how much practice you've had, it is entirely up to you whether you write that positive sign or whether you know that if you don't have to write a positive sign, because if you don't see a positive, it just still means it. So you could write nothing at all, or you could write the positive sign. It's entirely up to you. Okay? Then I do the numbers. 3 times 4 is 12. Then I take the letters one at a time. So the first one is an x, and then I just count. Now there's 1x here and 2 x's here. You could see it when I wrote it out the long way. There's 1x here and there's 2 x's here. So if I count them all up, that's 3 of them. And then I count the y's. Now in this case, counting the y's is easy because they put the number 2 there for me. This is y squared. So this was the long way, and it made sense. And this is the short way. So let's make up another example and let's do just the shortcut method, just to see how things work. So I will say we were going to do -4, 6, -1/2 a cubed b squared a b squared c. It's about as hard a question as I can make, but it's still a piece of cake. First, I work out the sign. So actually, let's make a note of that. So step 1 is the sign. So in this case, we have a negative times a positive times a negative. 2 negatives means this answer will be positive. Okay. 4 times 6, then the second thing you do is the number. And the technical term for this, which I can never spell, is coefficient. Do not ask me where that word comes from. I don't know. But anytime you see a number in front of variables, that's a coefficient. 4 times 6 is 24. Half of 24 is 12. So this is, again, 12. And now I do the letters, or I suppose the variables, and it's letter by letter. So I will start with the A's. 1, 2, 3 A's and a 4th A. So this is A to the power 4. Okay. Then I count the B's. That's 1, 2, 3, 4 B's. B to the 4. And then I count the C's. Well, there's just 1 C there. See, now I could have written this out the long way. I could have written A times A times A times B times B times A times B times B times C. I think I got everything there. And then I could count 1, 2, 3, 4 A's, 4, 1, 2, 3, 4 B's, and 1 C, 1 C. Now, people wonder, is it possible that I could scrunch these down even further? So it's attractive to think, I'm going to write this in another color because this is not true. It is attractive to think that I could have something like A, B, C, and then I could count this 4 and this 4 and this 1 and put a 9 there. It doesn't work. So you can only take it letter by letter, and that's it. But that's how you multiply. And when you get to the end, when you get to this, you get what is called a term. So a term is some mixture of a number and variables linked together by multiplication. Okay? And I will just emphasize for this, you should find this very, very easy. I don't think it's hard. I don't think very many people think it's hard. There are, ways if you're in a hurry, like, putting negative signs in the wrong place, or this thing we tried with the 9, that you can make small mistakes, but the idea is that we're building a foundation of skills that we can use all the time and really, really quickly. So if you're getting homework in a topic like this, just do all of it. And you really want it to feel like, oh yeah, this is easy. I'm plowing through it all really, really fast, because it's a skill that we're going to use all the time, and it's something that's really going to come in handy in the future.